Hello, everyone. Yeah, I'm really happy to give you a short overview of a new course I'm giving this year in France at École Polytechnique. So usually when a new professor arrives, he's supposed to write some textbooks, some documents and for the students for many years that they can use. But I was not very enthusiastic with this idea to have something written that you cannot change because you know that you always want to add some example, fix some typos. So this is why I decided to write some HTML web page and then convert that into some website. So this is a website that you have here the link. It is open. It is completely free. And there are several topics which are actually covered. You can see in the main menu, but let me just show that more in detail. So we speak about hypothesis testing, single, multiple comparison, also equivalence testing, linear, nonlinear models, mixed effect models, also linear, nonlinear mixed effect models, mixture models. And also we briefly present some problem for a change point detection, mainly in the mean and variance of a signal. And we also give some introduction to Bayesian restoration of images. I will just show that just after that. And what is really nice with the website that you don't have only pure static tests, but you can include a lot of interactive material. So of course we have a HTML web page, but we also have some movies, some web animations, and many Shiny applications as well, just because it's really nice just to better understand some concept using some interactive tool than just reading a text, of course. So I'm using R Markdown for this website because I'm not a geek at all. So for me, I need something easy to use. And that's really perfect for me because I can easily create web pages, convert that into a website very easily. So that's really nice. And the rendering, the visual rendering is really nice. It's very elegant, you will see. So that's very pleasant. You can easily insert a LaTeX equation, of course, R codes, and Shiny applications. So with that, for me, that was really exactly what I was looking for. And I'm really happy with this technical solution. So the objective of the course, of course, and this is not specific to this course, it's to learn to select the method, the good method for a given problem. How can we solve a problem? And for that, we use R. So that means that we need to know how to use a method which is implemented in R. It can be an R function, an R package. But we don't want to use R as a black box, R function as a black box, but just to go a little bit more in detail and really try to understand how the results which are returned are computed. So we want to be able to reproduce these results. And that's not always easy because in R there are very nice, a lot of functions, but they are not always well documented. And sometimes when you want to know exactly how a result is computed, it's not easy. But say, I spend a lot of time just to try to reproduce some results. Okay, so just maybe let me show you an example. I will switch. I hope that the web connection is working. A very, very simple example with regression models, just a polynomial regression, very, very basic. So when you use, for example, just to fit a linear model to some data, I will not discuss nothing about the data itself. It's not the objective of the talk. But you can hear when it's the stopping distance is a function of the speed of the car, which is a well-known data which is available in R. You can use, of course, LM as a function to fit this model, and then you get a lot of results. So, of course, it's important to understand these results. But as I said before, we want to go a little bit further and be really able to reproduce these results. So we really explain here what is a linear model, just to describe the math which are behind that. What is the least square method, how we can compute the least square estimate of the parameters, and then implement just now this formula just to check that we get exactly the same results. And we do the same with all the results, with the standard error of the estimate, etc., etc. So I think that's really important to have all this detail of the method available somewhere. And also, sometimes, of course, you will maybe not happy with an existing method, with some existing package, and maybe you want to implement yourself a method. So that means that you need to implement an algorithm. And that's also something which is important, to train a student to implement algorithms. And so here are some examples of the algorithm which are described and the student can easily implement. And all these algorithms, so EM for mixture models, a GIP sampler for simulation of a Markov random field, for example, simulated annealing for optimizing a complex function, or dynamic programming for a change point problem. All these algorithms are very, very easy to understand and very easy to implement. So that's important. So they don't have to spend a lot of time doing that. Let me just show an example for the GIP sampler. So again, of course, we describe first what is a Markov random field, what is a GIP sampler, etc. And then you see that this is the code just for implementing this algorithm. It's a binary here, Markov random field. And it's very, very easy to understand and for the student to implement. Of course, I'm pretty sure that there are some R experts that will say, oh, this is not very efficient because we are doing loop. This is not a course about R, but about statistics, computational statistics. And I don't care if it's the most efficient, but it's the easiest implementation to understand. And this is very important. Because this is really a direct implementation of the description of the algorithm, which is just an iterative procedure where we sample from the conditional distribution each pixel of an image. So this is exactly what we do. And it is very fast. I can tell you that for an image, it's really, really fast. So, and as I said before, we have also some shiny apps just to illustrate all these methods, all these algorithms, so we can easily then play a little bit with the student and show what is the impact of the regularization parameter, for example, when you sample, when you want to simulate a Markov random field. So, of course, again, this is only possible with a web page and on a textbook. It will be very difficult to do something like that. Okay, and there is then also the implementation of the simulated annealing, just for recovering an image. I will not show everything. Okay. Yeah, and just last point I want to mention is to learn a student, because when you want to study the statistical property of an estimator, for example, or of a statistical test, I think that now we should really intensively use a Monte Carlo simulation rather than pure asymptotic statistics, which is very nice and very useful. But for practical use, Monte Carlo simulation is really very, very powerful. So here is just, I think, a nice example. Just if you want, for example, to compare a parametric test or non-parametric test, just a t-test and a Wilcoxon test, for example. And, oops. So the theory, if you want really to derive theoretical result, it's not so easy, but it's very easy just with a very short, a few lines of R. You can really implement a Monte Carlo simulation, just doing 10,000 replicate in this example, over, where we will compare the power of the two tests, of the t-test and the Wilcoxon test. And it's interesting, for example, in this here, in this example, to see that if the data is normally distributed, then the Wilcoxon test is almost as powerful as the t-test, which is not something obvious. And you can really understand that if you do it, if you do the simulation. I think that's very, very important, just to convince the students of some important property to perform some simulation. And then, of course, if the data is not normally distributed, then you can easily show that, in this case, the Wilcoxon test will be much more powerful than the t-test. That's one of the many examples where we use the Monte Carlo simulation. Yeah, I'm finished. I'm done. Thank you.
Thank you very much. There's time for questions. Yes?
Yeah, they have access to, of course. And there are also some exercise. Oops, I have the connection now. Ah, no, this is, sorry, this is the PDF. Difficult to. There are some exercise as well. So they have, I give them the markdown file, and then they can just fill the blanks and etc., for example, but there are several exercises, and yeah, they work mainly with the website, and everything is online. Yes.
Other questions?
Yeah.
Yes.
It looks wonderful, and I was wondering, are you just demonstrating how you use standard tools to put this together, or was there some special additional tools used beyond the combination of Markdown and the Shiny and the other things? Or something?
No. No, the only thing that the Shiny apps are on a server, of course, because then they can have, several students can have access to the same apps, etc. And the only thing that I have also some web animation that I didn't show, but this is mainly what we use, R Markdown with Shiny apps and R. Yeah.
Okay, time for the last question. Yes? But they are very good students at Polytechnic. The third year of
So it's 9 days. Yeah, it's quite intensive. Yeah, but of course it's completely free to.
Okay, thank you very much.
Thank you.
Yeah.